Making a video. Yeah, stinking camera messed up. Anyway, I think I had to do a telephone call. Probably have to do another one, and it'll mess up again. Anyway, physics style video on TED Talks, and yeah, I just want to get over some of this pretentious language that these guys are always using, and just make the counter argument for why this is just such the wrong way to describe physics.
Years ago this month, a 36-year-old Albert Einstein stood up in front of the Prussian Academy of Sciences in Berlin to present a radical new theory of space, time, and gravity, the general theory of relativity.
Right. So it is kind of coincidental, right? Einstein was 36, I'm 56, 100 years later. Yeah, coincidences. Cool. Anyway, so yeah, well, he didn't really general relativity doesn't explain gravity. It's just a way of accounting for it. So that's the first way he's misunderstanding here. Einstein didn't add anything. He just gave you a reason, okay? And the reason is incorrect. But I mean, and it's bad in a sense that Einstein's gravity well, like I said, it's a nice little image, but it doesn't really explain anything because it uses gravity to push things down. And if you three-dimensionalize it, then you end up with something that sounds preposterous. Like I have an endless well inside of me, a vacuum cleaner, and it's pulling the universe into it. And there's an endless supply of universe to keep pulling in. And the bigger I make my vacuum cleaner, I can make my vacuum cleaner as big, and there's still plenty of air for me to pull. So it presumes two things. First, I can suck forever, and there's stuff to suck that's endless. Two presumptions that are not correct, that provide an inaccuracy, and that's what has allowed them to create singularities and to make matter do things it can't do, and all of that stuff. It's because it's not an accurate model. And so, Einstein didn't discover anything. He invented a cartoon that was kind of like Bugs Bunny, right? He's kind of like a person, but he's not really a person. And he can do things that we can't do. He can fall in the air for a really long time, and he can have conversations. He can run off cliffs and then run back. He can do all kinds of things we can't do. So he's not a very good model of what a human being is. I mean, Daffy Duck got his fucking head blown off so many times. His beak spun right around his face. Now, humans can't do that. See, it's a model, but it's really not a very good model. And sorry, general relativity is not an accurate model. It's kind of just a cartoonish explanation. And we should grow up and stop watching cartoons.
General relativity is unquestionably Einstein's masterpiece.
No. E equals mc squared was a masterpiece in the sense that it finally said what needed to be said. Just like God is dead, just like saying, why do we need this fantasy of religion? Just evolution, okay? E equals mc squared, evolution, these are key words, key things. But I mean, yes, the very idea of understanding that matter is holding energy. Energy is trapped in it. It's there, fucker. Really important. Understanding that matter isn't something different. It's fire and it's light and it's all that shit that's out there in there.
Theory which reveals the workings of the universe at the grandest scales.
Yeah, well, see, that doesn't do that. It's obviously because it's not the workings of the universe. The universe doesn't work the way Einstein's blueprint is, and it's incorrect. And now they're creating a lot of fake things to fix it because it doesn't fit. Something doesn't look like Einstein, and so therefore they invent dark matter and dark energy to contrive the universe that Einstein's describing. And it's a contrivance.
Capturing in one beautiful line of algebra everything from why apples fall from trees to the beginning of time.
Yeah, well, it doesn't do that either. Beginning of time, quantum mechanics doesn't give you any of that. Relativity doesn't give you any of that. So that's kind of bogus. And clearly, it doesn't explain it. And Newton knew all this stuff. Everybody knew about the convergence. Einstein didn't invent the idea of gravity, and he didn't invent the idea of time. And what he did was create, again, a fun little model to play with, but the model is not the reality. Time is not bent. Clocks move slower. If you're running in a foot race, and I tell you, go that way for a while. Go the other way for a while. Not the way the finish line is, but the other way for a little bit. You're going to understand you're not going to win the race, right? Somehow you're going to end up having run slower in the race. Well, obviously, because I made you go some other direction. Yeah, and that's what happens when you have a velocity. When you have a velocity, your metabolism slows down because your metabolism can't be doing what it was doing before. It has to do something else. So Einstein didn't get that one right. He got that one wrong. And it's important. These are important wrongs. And to talk as if you know, and this is all guaranteed, and you guys are blah, 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 it's just bogus.
Space. 1915 must have been an exciting year to be a physicist. Two new ideas were turning the subject on its head.
Well, like I said, really wasn't turning it on its head. This was theoretical stuff that didn't have much to do with the practical world. And Newton had already figured out the lens thing, that refractive index changes with the thickness of the glass. All on, all off, all on, all off. Well, twice as on, zero, twice, zero. And then with other glass indexes, you go from, 4%, 8%, 16%, 8%, 4%, So it was already there. Quantum mechanics was already a real thing. It just wasn't called quantum mechanics. I mean, naming something isn't exactly something to shatter Earths over.
One was Einstein's theory of relativity. The other was arguably even more revolutionary, quantum mechanics.
Well, again, so let's just understand what quantum mechanics is. Quantum mechanics is just the description of Newton's phenomenons, the phenomenon with the reflective index of glass and lenses, the thickness of the glass. And that's it. That's quantum mechanics. It's right there already. It already existed. And so they have a formula that describes that relationship, and they think that's something valuable. I don't think so.
Mind-meltingly strange, yet stunningly...
Yeah, see, mind-numbingly strange, yet stunningly successful. They keep talking about this success, and I'm just, I think it's bogus. Experiments create successes, and people already knew that you could bend crystals and create electricity. They all knew a lot of quantum mechanics without knowing quantum mechanics, because they knew the mechanics. They knew what it did. Again, Newton already knew the phenomenon existed. He already knew how to manipulate it to some extent. So it's kind of silly to say he wasn't already doing quantum mechanics.
Successful new way of understanding the micro world, the world of atoms and particles.
Well, again, the understanding is kind of not understanding, right? So again, you have a model of this little wavy stuff and all this kind of crap, and it's the wrong model. You've identified the wrong part being the one creating the changes, creating the diffractions, and getting it wrong is kind of important. You've gotten the fact that there's a pattern correct, but don't we all know that already? And you're creating a wrong explanation of how it got there and calling it a grand success. No, I think that's going to be the definition of failure, actually.
Over the last century, these two ideas have utterly transformed our understanding of the universe.
And again, I'd say that's just utterly excessive rhetoric. We already understood the universe. They already understood planets are circling the sun because they're accelerating towards the sun. They already are. I mean, none of our day-to-day lives changed one bit with this revelation. None of our fundamental understandings of how we interact with the world. So it's just kind of silly to say that, I think. It's just it's a silly thing to say.
It's thanks to relativity and quantum mechanics that we've learned what the universe is made from, how it began.
Again, does that make any sense to you? Quantum mechanics told us that the universe is made out of energy and mass. I mean, Einstein already did the E equals mc squared thing, so I don't think quantum mechanics made him understand that. So I don't understand how we didn't know matter and energy make up the universe, the simpler thing being the energy. The more complex thing being the matter. I think we knew that.
And how it continues to evolve.
Yeah, I don't think you really know that at all, so why are you talking so big like you got that answer, buddy? I don't think you have a clue how it's evolving.
100 years on, we now find ourselves at another turning point in physics, but what's at stake now is rather different. The next few years...
Yeah, the mega bomb, that's going to be, I'm going to do an Einstein on you people. I'm going to let you in on something. The whole universe can probably be blown up. Yeah, theoretically, I think I got that one. Yeah. You're really doomed. It's really easy to blow up the universe.
May tell us whether we'll be able to continue to increase our understanding of nature, or whether, maybe for the first time in the history of science, we could be facing questions that we cannot answer.
Yeah, questions that really don't matter. So, wow. Shucks. We can't answer the questions that don't matter. Now, let's make a whole book of questions that don't matter. How many hairs are on my head right now? Doesn't really matter, right? Do you care? Do you think it's a crisis that we'll never know? Oh, the pain. No. See, this is just all such hype.
Not because we don't have the brains or technology, but because the laws of physics themselves forbid it. This is the essential problem. The universe is far, far too interesting. Relativity and quantum mechanics appear to suggest that the universe should be a boring place. It should be dark.
Yeah, whatever. So, again, maybe you should think that maybe there's something wrong with relativity and quantum mechanics if they come up with a universe that should be dark and lonely and sad and pitiful. Maybe you should figure that maybe you got something wrong then. Because obviously the universe has little swirly bits and it's blowing up and all kinds of rays and all kinds of shit. But it is really simple, so let's not get silly about it, right? I mean, it is kind of a theme out there, right? A little swirly bit there, a little swirly bit there, a little swirly bit over there. I mean, it is all kind of just swirly bitty, right? It's certainly not walking and talking.
Lethal and lifeless. But when we look around us, we see we live in a universe full of interesting stuff, full of stars, planets, trees, squirrels.
Yeah, they're not all the same thing. So stars, planets, trees, squirrels is kind of cheating a little bit, okay? I mean, yes, there's this little thin layer of chemistry that gets really funky. But like I said, on the big universe scale, we see that chemistry doesn't do it any good at all. It doesn't get at all interesting. There's no, like... I'm just saying, I mean, galaxy, okay, well that one's spinning this way, and that one has a little bit bigger arms, and I mean, but it's just not very interesting. There's not a whole lot. It's bicycle wheels, I mean, they're all basically the same kind of thing. Okay, roundy round stuff, okay. Been there, done that, billion times. But, he had to throw in the fuzzy little hairy Earth to say, look, this is what the universe is doing. Well, no, most of the universe, by preposterous volumes, isn't doing anything like the surface of the Earth. Even the Earth, by preposterous volumes, isn't doing what it's doing on its surface. Most of the Earth isn't doing anything fun and human-y.
The question is, ultimately, why does all this interesting stuff exist? Why is there something rather than nothing?
Chemistry. But, oh, no, nothing. Oh, something rather than nothing. Why even play with that question, buddy? You're not going to be able to add anything to that question at all. You're really not. There's no footprints on that beach. Be careful how I turn this off so the camera doesn't fail. There's so many things you can't understand in this world. But, it's like women, right? So they can have a parasite infect them, grow for 9 months, rip them a new asshole where their vagina used to be, and they take that okay. But little light flashes on the dashboard, it's the end of the world. What do I do? Crisis. Anyway.
This contradiction is the most pressing problem in fundamental physics, and in the next few years we may find out whether we'll ever be able to solve it.
I don't know, contradictions. I don't, whatever. Again, yeah, like this is a big solution. Is going to be something. When you get your answer, you know, it's not going to. You're not going to be that impressed because it's just going to be some mechanical answer. It's not going to be interesting. Christ.
At the heart of this problem are two numbers, two extremely dangerous numbers. These are properties of the universe that we can measure, and they're extremely dangerous because if they were different, even by a tiny bit, then the universe as we know it would not exist. The first of these numbers is associated with a discovery that was made a few kilometers.
This is just so boring. You know, this whole frickin', oh, the universe couldn't, yeah, it would compensate, right? Everything would change relative to the constants changing, so there'd be some kind of universe. It just wouldn't be this universe. Amazing.
From this hall at CERN, home of this machine, the largest scientific device ever built by the human race, the Large Hadron Collider. The LHC whizzes subatomic particles around a 27-kilometer ring, getting them closer and closer to the speed of light before smashing them into each other inside gigantic particle detectors.
Well, really, I don't know if they really do that. Particle detectors, you're already in trouble right there. That's why they're not particles. But anyway, go ahead, have your little fantasies about your particles. Go ahead.
On the 4th of July 2012, physicists at CERN announced to the world that they'd spotted a new fundamental particle being created at the violent collisions at the LHC, the Higgs boson.
I didn't know this was going to be that.
Now, if you followed the news at the time, you'll have seen a lot of physicists getting very excited indeed, and you'll be...
okay, I didn't know this was going to be all this obtuse jibber-jabber, so maybe I'll spare you. I'll play it and see if there's anything of value in it, but, you know, I mean, this is all, you know, this stuff is all based on so many presumptions and assumptions. I mean, a list of presumptions built into any of their observations using that stupid piece of crap is just so preposterous that what's the point, you know? You know, you could go back and say, well, what if you were wrong about presumption 17? And then your whole universe blows up, buddy. I mean, one of your presumptions is wrong, your whole soup of bullshit is wrong. You can't, you know? Whatever. Alright, so I'm sorry, I thought this would be a video about physics. You know, I didn't know it was going to be this crap. Yeah. So I'll be back. Alright, so we're 7 minutes into this thing. So then it's not only that they got Higgs bosons now, that they have this Higgs field, you know, that fills the whole universe and blah blah blah, and it keeps everything together and blah blah blah. You're just like, no. Sorry, this is just nonsense. But anyway, and then so then he's going on the expansion of the universe thing and their invention of dark energy and how that doesn't work because quantum mechanics says it should be, you know, sort of 4 zillion times bigger, and therefore that won't work. You know, so anyway, now he's going to do string theory, so I just thought I'd let you hear it. I mean, it just sounds so fucking stupid. Well, go ahead, say it again, physics. Go ahead. Try to fool me again. No.
So that's a pretty bad prediction. In fact, it's been called the worst prediction in physics. And this is more than just a theoretical curiosity. If dark energy were anywhere near this strong, then the universe would have been torn apart. Stars and galaxies could not form, and we would not be here. So this is the second of those dangerous numbers.
And look, all this is based on, again, presumptions. And if they, you know, it's just this assumption that their assumptions are correct, right? They've assumed that redshift is consistent with velocity, and redshift isn't. Velocity away. You know, I mean, they're just wrong presumptions. They think gravity is something that happens to something automatically, and it's induced. You know, these are fundamental mistakes. Presumptions that are just fundamentally wrong because they have the wrong model.
Strength of dark energy, and explaining it requires an even more fantastic level of fine-tuning than we saw for the Higgs field. But unlike the Higgs field, this number has no known explanation. The hope was that a complete combination of Einstein's general theory of relativity, which is the theory of the universe at grand scales, with quantum mechanics, the theory of the universe at the small scales, might provide a solution. Einstein himself spent most of his later years on a futile search for a unified theory of physics and
Right, and yeah, he also conceded 2 years before his death that after playing with photons for 60 years, he doesn't understand them a goddamn bit better. And my argument would be is because, yeah, the model had gotten so abstract and warped that there's no way you could understand them if you accept the premises. If you're going to accept what you're telling us the world is, you're not going to find the answer because you have the wrong puzzle pieces. You're not going to be able to stick this thing together because it's not the right pieces. There's puzzle pieces from different puzzles. Cartoon, Bugs Bunny, and frickin' Mickey Mouse. You don't have much reality in this soup.
Physicists have kept at it ever since. One of the most promising candidates for a unified theory is string theory. And the essential idea is, if you could zoom in on the fundamental particles that make up our world.
So understand, fundamental particles is where all this always breaks down because they really haven't properly identified what a particle is, what a fundamental particle is. And not understanding that the things you're calling particles are colonies of particles is a pretty big mistake. It's like me calling you a bacterium. It's just a big mistake. Technically, probably.
You'd see actually that they're not particles at all, but tiny vibrating strings of energy, with each frequency of vibration corresponding to a different particle, a bit like musical notes on a guitar string.
Right, isn't that all so cute and pretty? I mean, that's such a physics kind of mentality, you know, where you go in, let's zoom in and find the little men working on the neutrons, the neutronians, and they're pulling the strings. Is that what's going on? The neutronians are playing the strings. Positronians. The neutronians hate the positronians because they're the friggin' positronians they have really good, cool golden strings, and the stupid neutronians have these stupid, ugly brown strings. And the electronians, it really is that funny, isn't it? Come on, seriously. Oh, zoom in on the universe and let's turn it into guitar strings. That makes sense. Oh yeah, guitar strings. Yeah, all strung on guitars somehow. Fuck.
So it's a rather elegant, almost poetic way of looking at the world.
It's like poetic, like the stuff I poo every day. It's about as poetic as that. I don't poo every day.
But it has one catastrophic problem.
I laugh so hard that my brain stops thinking about it because I'm laughing so hard. I mean, I can't. Holy shit! I can't comprehend it because every time I hear it, it's the funniest joke I ever heard. I mean, come on.
It turns out that string theory isn't one theory at all, but a whole collection of theories.
Oh, now you tell me. It's a whole orchestra. And, you know, I think it's just better. Just turn into little men. So let's just forget all this stuff. We'll have the Higgsians and the neutronians and the protonians and the electronians. That's much better. And they just say they're at war with each other, and you can just, you know, let's create a much better fantasy. I mean, if you're going to write a fantasy novel, why don't you just write a good one instead of this silly one?
It's been estimated, in fact, that there are 10 to the 500 different versions of string theory.
Each one just adds some more dimensions to pretend, you know, they can put all the stuff they don't understand in the wacky dimension. You know, that part you don't understand, yeah, that's in the wacky dimension. You don't have to worry about that because that barely ever leaks into our dimension. Except, you know, on the 4th of July and Hitler Day.
One would describe a different universe with different laws of physics. Now, critics say this makes string theory unscientific. You can't disprove the theory. But others actually turned this on its head and said, well, maybe this apparent failure is string theory's greatest triumph. What if all of these 10 to the 500 different possible universes actually exist out there somewhere in some grand multiverse?
Right, I mean, that's nothing like just inventing electronians, right? What's more practical? Electronians are a zillion alternative universes all running on a different system and speaking a different language and such. Speaking English backwards. Yes, it's exactly like this universe, except everybody speaks English backwards. What's more realistic? I mean, I'm just saying, as a pragmatist, I'd probably vote that, okay, if I had to actually pay for it, you know, building all the universes or just building Electronians, I'd say go for the Electronians. That seems a little simpler.
Suddenly, we can understand the weirdly fine-tuned values of these two dangerous numbers. In most of the multiverse...
I missed that part. Damn. It was so damn sudden I missed the understanding part because, yeah, I don't understand it at all.
Dark energy is so strong that the universe gets torn apart, or the Higgs field is so weak that no atoms can form. We live in one of the places in the multiverse where the two numbers are just right. We live in a Goldilocks universe.
Oh, Goldilocks planet in the Goldilocks universe. This is all sounding like Goldilocks, isn't it? I mean, it just sounds like a little story, don't it? Little gingerbread peoples, and why don't we make the Electronians out of gingerbread? That'll solve a lot of problems. That's a lot cheaper than guts and sinew and all that stuff. So yeah, let's just say they're gingerbread men, that are the Electronians are gingerbread men. There, that's a lot better. I mean, you people are eating this stuff like, oh, that guy's smart, man. I don't understand what he's saying, so he must be smart because he's saying that stuff makes sense. Yeah. No, it's a pile of shit.
Now, this idea is extremely controversial, and it's easy to see why. If we follow this line of thinking...
Yes, if we follow this line of thinking, you might as well not think at all, because it's just making everything up, and it's just a pile of crap, and I can do that all fucking day. You want me to tell stories? I can tell stories all day fucking long. Silly little stories about the Electronians, and their hard little... their battle to endeavor to persevere. They had that whole war with the Hoobies, you know, and then Horton got involved, and then they, you know, they speared the fuck out of his butt.
Then we will never be able to answer the question, why is there something rather than nothing? In most of the multiverse, there is nothing, and we live in one of the few places where the laws of physics allow there to be...
Gee, yeah, well, that's a little bit more convenient, I have to admit. Okay, if most of the universes you make don't have to have anything in them, oh, shit, yeah, that makes it a lot more economical. Yeah, I'll finance that. I'll finance the construction of a bunch of multiverses that don't have anything in them. That sounds cool.
Something. Even worse, we can't test the idea of the multiverse. We can't access these other universes, so there's no way of knowing whether they're there or not.
Well, there sort of is. If you find some of your, whatever, dark matter, or maybe you could find some dark matter with an Electronian, you know, that's from the other universe, and he'll be speaking backwards. And then you'll know he's from the multiverse.
So we're in an extremely frustrating position. That doesn't mean the multiverse doesn't exist. There are other planets.
Somebody should take Occam's razor and just cut this guy's head right the fuck off with it. I mean, come on, man. Fuck, you're a physicist. You get, no. Isn't there some rolling ball answer that's a little simpler than this shit? Please.
The stars are the galaxies, so why not other universes? The problem is, it's unlikely we'll ever know for sure.
Well, it's theoretically nonsense in the sense that, what? How would the other universe communicate with our universe? It'd have to smash into it and create some sort of thing. There'd be an event. You can't be breaking no holes in the universe without somebody noticing that kind of shit. I'll be back. Hello?
Hi, Mr. Gary. My name is Jonna with Elite Aviation Products.
Oh, wow. How interesting. She's from Elite Products. Interesting. But just so fucking fast. Thank you for calling and everything. Fucking cunt. Mr. Gary. Now, why aren't those people being hacked to pieces by Occam the Razor too? It's just such an annoying world. Why are we tolerating this shit? I gotta beat these people to death with dead Muslims. Anyway, moving on. I hit the button. So you get the call, and then I hit the button. Yeah, that's really clever, Gary. Alright, multiverse for a while. Let's get down with this
Last few
shit.
years, we've started to get the first solid hints that this line of reasoning may get borne out.
Yeah, fuck you.
Despite high hopes for the first run of the LHC, what we were looking for there, we were looking for new theories of physics, supersymmetry, or large extra dimensions that could explain this weirdly fine-tuned value of...
Let's just understand, they're for all this equipment, this nonsense, all they're really doing is converting matter, little bits of neutrons, hurling them so fast that they turn into light, essentially, photons, and then smashing them into other photons, and then they're seeing the little parts that fly off that seem to be almost, oh, look, that almost looks like a collection of something. It lasts for a billionth of a second. They say that's a particle. It lasts for a billionth of a second. They say it's a thing. They call it something. I mean, it's somebody doing diarrhea on a painting and just waiting until they get a painting that looks like Richard Nixon and then saying that's the Richard Nixon particle. This is what they're really doing, and their microscope doesn't get any better. You know, they're never going to see photons, and they're never going to see any of this little shit. They're just going to keep seeing trails in cloud chambers, and that's all they have to work with. So, I mean, all this bullshit that this thing is doing something, it's not doing anything. It's throwing spaghetti on the wall and just waiting until they throw some that looks like something. Yeah, you throw enough spaghetti. It's the monkeys and typewriter thing, you know. You throw enough spaghetti on the wall, eventually there's going to be a piece of it's going to look like whoever, somebody famous, Albert Einstein.
the Higgs field. But despite high hopes, the LHC revealed a barren subatomic wilderness populated only by a lonely Higgs boson. My experiment published paper after...
Oh, yeah, whatever. You didn't find any of those anyway, so this is all just such a crock of shit. You found some fucking mutant third cousin of a Higgs boson and just assumed, well, there must be a retard somewhere around here because this kid is fucking retarded. There must be a retarded parent somewhere.
Paper where we glumly had to conclude that we saw no signs of new physics. The stakes now could not be higher. This summer, the LHC began its second phase of operation with an energy almost double what we achieved in the first run. What particle physicists are all desperately hoping for are signs of new particles, micro black holes, or maybe something totally unexpected.
I hope they catch their asses on fire, frankly. I mean, this is just such crap. They blow the thing up.
Emerging from the violent collisions at the Large Hadron Collider. If so, then we can continue this long journey that began 100 years ago with Albert Einstein towards an ever deeper
Right, that's, you know, the phantasmagorical cartoon universe forever. Cartoon universe and beyond! That's all they're doing. They're living in a cartoon. They're trying to make the cartoon real for everybody. I mean, it really is a holographic universe. I mean, we're just heading for a place where we turn ourselves into vacuous cardboard, mechanically vacant crap to suit this guy's vision of the universe.
Understanding of the laws of nature.
These are the laws of human nature, which is lie, you'll make up a fib. Oh, you should have saw that fish I almost caught. It was like a fucking as big as 14 Higgs bosons end to end, man. It was a fucking big fucker. You're just storytellers.
But if in 2 or 3 years' time, when the LHC switches off again for a second-long shutdown, we found nothing but the Higgs boson, then we may be entering a new era in physics. An era where there are weird features of the...
Yeah, maybe you just leave the damn thing off. Yeah, why waste the electricity?
...universe that we cannot explain. An era where we have hints that we live in a multiverse that lies frustratingly forever beyond our reach.
It just seems kind of silly to say, if you're going to damn invent this stupid thing, then I think if you can invent a whole universe out there, I think you probably can invent some kind of silly bridge that'll get you there. Silly universe, silly bridge. Why not? Silly bridge doesn't sound like much work at all.
An era where we will never be able to answer the question, why is there something rather than nothing? Thank you.
Because nothing is probably taxed just as much, and so it really doesn't matter much. So you might as well have something, but you're going to pay the nothing tax anyway. It's probably something like that. So what, there's 10 minutes of applause on this thing? He's done. But this video ain't nearly done. Alright, let's see what it is. Let's see who's not applauding. There's got to be somebody not applauding.
Hey, even if you just said the science may not have some answers, I would like to ask you about.
Oh, I represent BMWs and such. These make cars. Do you have anything in your fucking stupid collider to make a car go a little faster and such? Make the tires Higgs boson into the road and rip it to shit so the car go faster? You have any of that for us with this collider thingy?
Questions. And the first is, building something like LHC is a generational project. I just mentioned introducing you that we live in our short...
Yes, you was hatched there, wasn't you? You was like born of physicists and physicists. And they hatch your egg there with all the radiation, right? So you're going to die of cancer by the time you're 32, right? I'm German, so I sell a lot of fucking medicines and stuff, so maybe you want some of that stuff.
Term kind of world. How do you think so long term, projecting yourself out a generation and building something like this?
Yeah, I mean, I was very lucky that I joined the experiment I work on at the LHC in 2000.
Ah, look at all this writing on they put on my videos. Brian Green. Scumbaggus, creepy little fucker. Anyway, he joined the LHC when he was 14.
Just as we were switching on. And there are people in my research group who've been working on it for 3 decades, their entire careers on one machine. So I think the first conversations about the LHC were in 1976. And you kind of start planning the machine without the technology that you know you're going to need to be able to build it. So the computing power did not exist in the early 90s when design work began in earnest. One of the big detectors which record these collisions, they didn't think there was technology that could withstand the radiation that would be created at the LHC. So there was basically a lump of lead in the middle of this object with some detectors around the outside. But subsequently, we have developed technology. So you have to rely on people's ingenuity.
It's probably some of those extra crazy Muslims. You could probably make radiation shields out of crazy Muslims. Yeah, I think it's a good idea.
Will solve the problems, but it may be a decade or more
rapey Muslims
down the line.
Now, China just announced 2 or 3 weeks ago that they intend to build a super collider twice the size of...
Yes, but they also said they want to make a universe, multiverse. They said the next project will just be, hey, fuck making this stupid stuff that nobody lives in anyway. We'll just make we'll make a whole universe someplace else, and we're going to fill it with electronians, because, yeah, they're kind of cool.
The LHC.
Yeah.
I was wondering how you and your colleagues welcome the news.
Well, science isn't everything, Bruno.
I'm sure. I'm totally sure of that.
It sounds funny for a particle physicist to say that, but
science isn't everything, sir. It's the stinky Chinese people. We don't want none of that, right? We don't want none of that Chinese science. Fuck the Chinese science fuckers. Yeah, fuck Chinese science. Yeah, it's a good Muslim science.
I mean, no, seriously, it is great news. So, building a machine like the LHC requires countries from all over the world to pool their resources. No one nation can...
So let's just understand, right? China makes whole cities that nobody lives in. China wants to make anything. It doesn't care. So it's just, oh, you mean we can spend zillions of dollars making some loop-de-loop thing? And everybody will, like, think it's cool? Okay, we'll make one of those. What the fuck? We make things here. That's what we do. Not necessarily useful things. You know, we just... got a lot of steel to use up and shit. We got all this fucking stuff to use, so yeah, might as well use it.
can afford to build a machine this large. Well, apart from maybe China, because they can mobilize huge amounts of resources, manpower, and money to build machines like this. So it's only a good thing. What they're really planning to do is to build a machine that will study the Higgs boson in detail and could give us some clues to whether these new ideas like supersymmetry are really out there. So
yeah, they're really just cartoon characters. They're going to find Bugs Bunny. He's been lost for decades, and they're going to find good old Bugsy caught in that holographic cartoon world. And they're going to bring Bugsy home. They're going to bring Bugs Bunny home. Physics. I mean, this is Cartoon Network.
it's great news for physics, I think.
Harry, thank you.
Thank you very much.
Thank you. I'm gonna get that guy to interview me. Yeah. Yeah. So you completely take over all of science. You call all the physicists retarded. Okay, I probably agree with that. It all was retarded. I was saying, you can't make BMWs better. There's no point. You can super collider and all this stuff, but you can't make the cars already perfect. It's a perfect car. You can't make it better. I was telling them that. Just like you. Alright, anyway. Till next time. Maybe I'll find somebody rational on Earth to discuss physics with. Not looking too good.